So now let us take a look at how to calculate coordination number and oxidation number of the complex. Coordination number and oxidation number of a coordination complex. So we will take all these complex and we will try to predict what is the coordination number and the oxidation number in this complex. So coordination number is nothing but number of coordination bonds. Number of coordination bonds. Number of coordination bonds. Oxidation number I am talking about the oxidation number of the central metal ion. How to calculate is very simple. That is charge on the complex. Charge on the complex is equal to actually oxidation number plus charge on the ligand. Charge on the ligand, correct? Charge on the complex ion, oxidation is equal to oxidation number plus charge on the ligand, or else the oxidation number of the central metal ion is equal to charge on the complex minus charge on the ligand. Charge on the complex minus charge on the ligand. So coordination number, let us take a look. So we will be talking about the complex ion. We don't consider the counter ion at all here, only the complex ion required. Number of the coordination bonds made by the ligand. How many monodentate ligand we are having? 4 monodentate ligand. Monodentate ligand is the one which has only one coordinating atom or which can able to link to the central metal ion using only one coordinating atom. That is how many monodentate ligand we are having? 4 monodentate ligand. That means we have a 4 coordination bond between copper and the ligand. All the coordination number in this complex is 4, very clear. Coordination number in this complex is 4. Here if you consider how many monodentate ligand we are having, we have 6 monodentate ligand. That means we have 6 coordination bond between the cobalt ion and the ammonia. That means the number of the coordination number in this case is 6. In this case again the coordination number is 6 because it is a monodentate ligand water. It can make 6 bonds with the 6 bonds with the cobalt ion. Here the again Cn minus is a monodentate as well as it's an ambidentate ligand. Ambidentate or monodentate doesn't matter. It will make only one bond with the central metal ion. One ambidentate or the monodentate ligand, and hence we have 6 ligands we have cyanide ion. It can make 6 coordination bonds. Again it is a 6 coordinated complex. Here it is a 4 coordinated complex. Clear? So this is how we can calculate the coordination number. For instance, if they had given CuEn, En means it is ethylene diamine, student. CuEn twice. This is the complex ion you have. So what is the coordination number of this particular complex? Just check ethylene diamine. Ethylene diamine is a bidentate ligand. Ethylene diamine is a bidentate ligand. A bidentate ligand is the one which makes 2 bonds. A ligand will make 2 bonds. 2 ligands we have, it will be making 4 bonds with the central metal ion, right? That means we have 4 coordination bond, or coordination number of the complex is 4. Similar way, if at all they mention like cobalt, OX 3 times, right? OX 3 times, oxalate ion, right? OX 3 times, 3 minus for example, right? If at all they mention like this, just check here, oxalate ion we are having. Oxalate ion is COO minus, COO minus. That means 2 coordinating atoms we have. That is again it is a bidentate ligand. It's a bidentate ligand. Bidentate ligand is the one which makes 2 bonds with the coordination center, right, or the central metal ion. How many bidentate ligands? 3 bidentate ligands. That means number of coordination bond is 6, or the coordination number of the the complex ion in this particular complex is 6. For instance, if at all they mention like, you know, the chromium EDTA, chromium EDTA, whatever could be the charge. For example, 2 plus is the charge, right? If at all they ask you what is the coordination number of this. See, EDTA, ethylene diamine tetraacetate ligand, is a hexadentate ligand. Hexadentate ligand. That means a ligand will make 6 coordination bonds. One ligand we have a 6 coordination bond between the chromium and the EDTA, or in other words the coordination number of this is 6. Clear? So this is how we can calculate the coordination number of the complex ion or the coordination complex. So what is a coordination number? Coordination number is the number of coordination bonds in a complex ion, or the coordination complex is what is referred as coordination number. Clear? Now the oxidation number. Oxidation number can be calculated. Oxidation number of the central metal ion is equal to charge on the complex minus the charge of the ligand, right? What is the complex charge? How did you split this? This is splitted into Cu ammonia 4 times 2 plus, right? Cu ammonia 4 plus 4, 2 plus SO4 minus 2. It has to be 2 plus because SO4, the counter ion, it is having a same charge as that of the, you know, the charge of the complex, but it is having the opposite sign, right? So this is a plus 2 charge, this is minus 2, right? So that means the charge on the complex is 2 students, right? Plus 2 is the charge on the complex. Is there any the charge on the ligand? See, there are 2 kinds of the ligand. Again, we might have seen this, right, students? This is a cyanide ion, Cn minus. This is a negatively charged ligand we are having. We are having the neutral ligand also. Ammonia is a neutral ligand, water is a neutral ligand, carbonyl is a neutral ligand. I will not go details into it. NH3, right? You have a lone pair through which it has bonded. On the other hand, if you are having CH3COO minus, so this is a negatively charged ligand. Negative charge is being utilized for establishing a coordination bond. Here the lone pair of electron. For example, water, oxygen lone pair has been utilized. That means it is a neutral ligand, right? Neutral ligand, that means it doesn't carry any charge. Neutral ligand, that means it doesn't carry any charge. So neutral ligand, it doesn't carry any charge, so it will not be, you know, balancing the positive charge of this. Ligand is not balancing the positive charge. The ligand is neutral. Ligand neutral, whenever you are having only neutral ligand, charge on the complex ion is equal to the charge of the central metal ion, because this is not, you know, counteracting the ligand, right? So counteracting the, you know, the charge of the complex, charge of the central metal ion also. I am sorry, this is not countering the charge of the central metal ion. So charge on the complex is plus 2 here, right? Charge on the ligand is 0 anyhow because it is a neutral ligand. Hence the oxidation state of the ligand is 2. I am sorry, oxidation state of the central metal ion in this particular complex is 2. That is, copper is in the plus 2 state. How about the oxidation number of this, students? This is, how did you split it? CO ammonia 6 times 3 plus 3Cl minus, because this is again a neutral ligand. This is again a neutral ligand. Charge on the complex is 3, right? And the ligand doesn't have any charge. That means the charge of the central metal ion is plus 3. Or the oxidation state of the oxidation number of the central metal ion is plus 3. Very clear. In this case, what is the oxidation state of the central metal ion? Plus 2 is the oxidation state of the central metal ion, because again it is a neutral ligand. 2 Cl minus ions are there. Here, on the other hand, here, see what is the charge on the charge on the complex ion is minus 4 is the charge on the complex ion, right? Minus 4 is the charge on the complex ion. Charge on the ligand, it is a Cn minus ion, students. Try to understand, it's a Cn minus ion. Cn minus ion, it is a negatively charged ligand. How many Cn minus ions are there? 6 Cn minus ions are there. That means charge on the ligand is minus 6. Charge on the ligand is minus 6, or oxidation number is equal to charge on the complex minus 4 plus 6, because I am taking this into this side. Minus 6 goes to the plus 6. That means the charge of the central metal ion is plus 2 here. Charge of the central metal ion is +2. Clear? So charge in this case, the Fe is in the +2 state. Whereas here nickel tetracarbonyl, it is the charge on the complex ion is 0 because there is no counter ion. This is a neutral ligand, CO is a neutral ligand, there is no counter ion. That means nickel is in the 0 oxidation state. They may ask you what is the oxidation state of the nickel in the nickel tetracarbonyl, it is 0. What is the oxidation state of the iron in this one, potassium ferrocyanide complex, it is +2, and so on and so forth. One of the question which could be asked students, they may ask you like coordination number of the complex and the oxidation number of the central metal ion in the Cu ammonia 4 times SO4 complex is respectively what and all. Answer them. Nickel tetracarbonyl, the coordination number and the oxidation number. Coordination number is 4 and the oxidation number is 0. That is how you can predict the coordination number and the oxidation number. One of the aspect where the question can be asked. Okay, so this is about the coordination number and the oxidation number.